See the mechanism how this is taking place in the case of Kolbe's electrolysis. So first step that is taking place is the ionization, and for easier ionization only we are taking the sodium or the potassium salt of the carboxylic acid. We know that once the carboxylic acid is not so active compared to the sodium or potassium salt. So that is the only reason why taking the sodium or potassium salt. So first step taking place in the Kolbe's electrolysis is the ionization. So first step can be considered as ionization. Okay. So for this ionization, we can say, suppose you integrate take sodium acetate. So you need 2 molecules of sodium acetate. So we can say that 2 molecules of sodium acetate will be ionizing. How it will be ionizing? It will be ionizing to give the acetate and the sodium ions. So it becomes CH3COO minus, that is the acetate ion, plus the sodium ion, plus 2 Na plus. So this is acetate ion. Okay, so you have the sodium acetate. First step, sodium acetate undergoing ionization to give acetate ion and Na plus. Now we can say it is the electrolysis that is taking place. Electrolysis means you have an anode and you have a cathode, and towards the anode. Okay, anode is positively charged, and towards the anode we can say that the anions will be migrating. Okay, we can say, so we'll see what happens at anode. Okay, we can say anode is positively charged. Towards the positive charge, the anions will be migrating. So here anions are acetate ions. So we can say the acetate ion will be migrating towards the anode, and these acetate ions will be removing. Okay, will be losing 2 electrons. You have 2 molecules of acetate ion, and each ion will be having a single electron. So you can see that it will be removing 2 electrons from it, and thereby it becomes a radical, acetate radical. Okay, so it becomes CH3COO radical. So radical is represented as a dot. Okay, you're getting an acetate radical. You are getting acetate radical plus, so you have okay, the first step is the acetate radical formation. Next what happens is that from this particular radical, the carbon dioxide will be easily lost, and thereby it becomes the methyl radicals. When the CO2 is lost, means it becomes methyl radical plus you get carbon dioxide, and this carbon dioxide being vapor, it will be lost. Okay, it is vaporizing, it will be lost, and that is what it is shown by the upward arrow. Next we can see that there is a methyl radical formation. So here we have the methyl radical formation. In the second step, what happens is that 2 methyl radicals. Okay, 2 methyl radicals will combine, and therefore you get the ethane. Okay, so this is what that is taking place. So you get ethane over here. Okay, even ethane is a gaseous product, it can escape. Okay, so these are the 2 methyl radicals. So this is a reaction that is taking place in the anode. Now we have got to see what happens at the cathode. So at the cathode we can show, okay, in this case cathode is negatively charged. Cathode is negatively charged, and therefore towards the cathode the cations will be migrating, and here we can say at the cathode we have the electrolysis, we have water, and here at the anode the two electrons are released, and these electrons will be taken up by the water, and this water will be converted to OH minus ions and hydrogen radical. Okay. OH minus ions and the hydrogen radical, and this is only one water molecule. Suppose you have two water molecule, two electrons will be added, two OH minus ions, and will be having two hydrogens released, and these two hydrogens combine to give H2. Okay. And also we know that there are Na plus ions, and these Na plus ions will also be migrating to the cathode, and that can react with that of the OH minus ions. Okay. It can react with that of the OH minus ions, and thereby you get Na. So these are the reactions that are taking place at the cathode. So this is the mechanism of the Kolbe electrolysis, very important.